Thank you, Sally, for awesome introduction, and glad to hear, glad to be here with you all. And it's awesome that we can meet amidst the pandemic like this.
Yeah.
Uh, and without further ado, let's jump into the topic. I personally am very passionate about this topic, and I had the fortune of implementing some projects using MLOps as it was developing throughout these years. Just let me know if you're able to see the screen and then we get started.
Yes, sounds good.
Awesome. So glad to be here once again. Just so I introduce myself, I just made a slide of who I am. So basically, as most of us are from Helsinki, I'm based in Helsinki. I work at TietoEvry as a senior machine learning engineer, and I have 6 years experience in AI and machine learning. And I've worked in companies like Silo AI, Bankiton, and some startups in my previous experience. And also, I have graduated from Arcada University of Applied Sciences as part of the Master of Engineering of Big Data Analytics. And apart from my AI and machine learning, I try to keep it fun, enjoy traveling, meeting people, and playing cricket. As I come from India originally, so cricket is a special sport, and I've been fortunate to work with MLOps as it was developing, especially, and it was booming in the last 2 years. So I decided to write a book about it, especially because MLOps is dynamically developing, and there are a lot of scattered information on the web, and it is hard to wrap up our head sometimes with all this information. So I took this opportunity to compile this book, and it's coming out very soon. So today I'll be presenting some of my learnings that I've had working with MLOps throughout the years. And also, one of my hobbies is to keep myself acquainted with research and participate in it actively, and especially in the topics of edge and cloud computing, MLOps, natural language processing, and computer vision. So if you're into research as well, uh, please feel free to share awesome ideas that we might be working on. So before we jump into MLOps, I think there are different kind of people here in the meetup. Some come from business background, some from mostly from data scientists and machine learning engineers as well. So just to take it a bit easy, let's look at how AI is changing the world. Right now it's 2021, and already we can see the transformation happening, and it is anticipated from these sources like Gartner, PwC, Wired, New York Times that by 2022 there'll be 75 million jobs lost because we see automation is all around us, especially with the pandemic, and there'll be 133 million new jobs created during this time. So there's a big transformation going on. And as a result of this, economies also are changing, and there'll be a huge economic growth of 13 to 15 trillion anticipated by 2030. So this is all exciting times to be part of this transformation. It's a great opportunity to learn, evolve, and thrive. And I guess many of us have heard about Andrew Ng, who's a famous influencer in the AI world. And in 2016, when I was kind of new to AI and finding my way through building machine learning solutions in the market, I came across this quote by Andrew Ng, which says that AI is the new electricity, and it caught my attention. And when we look at how electricity came into this world, when electricity was invented, it still had to reach to all the homes and all the devices that we have today. So, in order to do that, we've developed a mechanism to mass produce electricity through factories. And in the same way, we are right now with AI as well. And AI is the new electricity, as Andrew Ng says, and we need a mechanism to mass produce AI and ship it out to companies, homes, and all around the world to actually see the full potential of AI come to light. So I believe this factory here is evolving to be MLOps. And today we'll look at this MLOps. And MLOps is, in simple terms, a software engineering approach which enables organizations and AI developers to collaborate in order to automate uh, machine learning operations. So we'll look into it. And before we go into MLOps, we'll look at the problem that's there at hand and what MLOps is solving right now. So as we can see, multiple sources have stated like Gartner and VentureBeat. They've stated that 60% of data science projects have failed in 2016, and it kept on increasing because there was a lot of hype from 2016 around AI, and many companies, many people were trying to build cool stuff out of AI, but many failed. Uh, and also in 2019, 87% of data science and ML efforts are failing, and they never get to impact businesses. And when we look at it, why is it so? There's a famous influencer called Singh, and he analyzed the market trends, and he came up with these three factors that are quite prevalent in the market because of which the AI projects are failing. So if you look at it, companies are not able to apply AI and generate business value for various reasons. It can be cultural, it can be the way they operate, and it can be many other factors. And also, there's a lot of hype still in the market. And thirdly, and most importantly, I think this is where the key is to unlock the full potential of AI. It is to enable continuous learning, and because of lack of continuous learning, we are not able to realize the full potential AI has to offer to realize the business value that it can offer. So just that we're getting into ML ops now, we'll just look at how AI in research is different from production, just to understand from two different lenses of how things can be, because it's very different in research and it's very different in industry when it's applied to solve business problems. So when it comes to these parameters such as performance, priority, data fairness, interpretability, complexity, and the other parts. The focus in research is to always challenge the state of the art, but in production, it is we need models which are better than simple models, which are able to efficiently do tasks and generate business value. And when it comes to training, the focus in research is fast training, and production, it is fast inference. And when we look at the nature of data in research, there's usually static data sets that researchers work around to develop models, but in production, the data is constantly changing. So it's very different in this case. And yeah, all of the rest of factors, as we can see, how production is different from research, especially fairness and interpretability. It is good to have them in research and not so important in production in many cases, but these days it is important because we can see a lot of debate going around the way AI is making decisions in our everyday life. So hence it is important in production. And uh, Everything else in production seems to be a bit different from how things are done in research. So the way also software development has been shaping up. It's pretty interesting actually. We started from the waterfall model where it was unilateral, where we developed software in one direction without much iterations, and it was how we started to develop software when internet came, and then we moved to the agile methodology where we develop software in iterations and sprints with interaction with the user, taking the feedback. So there was some development. And then we went on to the DevOps, which is quite popular for enabling an IT mindset of collaboration, communication, integration, and automation. And it has stages like build, test, and deploy. If you're a software engineer, you must be familiar with that. So this is how software has been changing, and we'll look at some other trends which are leading to MLOps to understand how it is making an impact, and also just not to go much into detail because of brevity of time. The point of this slide is computation is improving every year, and because of that, we're able to produce state-of-the-art deep learning algorithms like AlphaGo or even GPT-3 and these sort of algorithms. And uh, computation is improving by 35 times every 18 months. That is the rate at which we are improving the computation. But of course, we will hit a roadblock. It can't keep on going like this. And we are moving to new trends where we are seeing distributed computing, where the computation is distributed across multiple nodes. So, how do we cope with this sort of changing computational behavior? And also, how do we deal with the nature of data, the big data, the volume of data? It's huge these days, the velocity at which it is being generated, the veracity and the variety in terms of structural and unstructural data and the different formats, image, audio, and different formats in which the data resides and is generated. So how do we deal with all of this mess? And we simply cannot do it by the old ways of doing. Of course, the world is changing. We also need to evolve. And thanks to machine learning operations, this MLOps method that we have developed, the AI world has developed to deal with all of these trends of dealing with infrastructure, dealing with the changing trends in data, and also dealing with the nature in which the software is developed. So, in a nutshell, MLOps is the DevOps of machine learning, and it's a hybrid of DevOps, of course, which takes into consideration the data, code, and machine learning models to generate business value. And let's see how it is different from DevOps. So, the way we develop in DevOps is we keep data and code separate. Usually, we don't version data. At least we version the data. We have version control for data. But in that case, when we don't version data, the code that we keep developing and the data that is constantly changing in production is dynamically going in different directions as the time progresses. So we see that's why the data and code are going in different directions, and it's hard to maintain both as we go and progress along the time. And this is where MLOps plays a crucial role to tie data and code together by enabling versioning for data, versioning for code parallelly, and tying them both together to enable machine learning operations in production. So the way MLOps does is it uses code, it fits to the data to generate the models, and it maintains the version of data, code, and models. So all of these three are tied up together, and it makes it easier to develop software in this manner. And in a big picture, the skills that are needed to make machine learning operations is a combination of data engineering, where you build data pipelines to fetch your data, and you need to have DevOps skills and also machine learning skills to build the models. So the fusion of these three is coming together to enable machine learning operations. And this is how data science life cycle goes on these days, where we start by understanding a business problem, where we get the business understanding, we understand the value chain, we understand the use case, we map out the data, and then we do the data analysis. For the acquired data, we build pipelines and we version the data and store the artifacts. And this, in a nutshell, is the bird eye view of machine learning operations, of how it enables the data science lifecycle uh, in an efficient way. And of course, using this data, we develop machine learning models by doing feature engineering, model training, model evaluation, and packaging. And good thing is all of this is enabled using continuous integration and continuous deployment to deploy these models that we develop in various ways as APIs, as streaming service, as batch service, and so forth. So this, in a nutshell, is the bird eye view in which the MLOps enables to give us business value from solving business problems using machine learning. And When you look at how we productize machine learning, uh, we need to have keep this in mind. I always keep encouraging people to look at it this way. It's not about building cool models and deploying them. It is more about building the pipeline, as the pipeline is the product, not the model when it comes to productizing machine learning. Because the better pipelines, the robust, the secure pipelines you have to operationalize your machine learning operations, the better you're able to serve your users and generate business value. So this is a way of thinking, and pipeline is a product. And I want to present to you today the MLOps workflow that I've developed together with all my colleagues and mentors, of course, throughout these years using this uh, data science approach, data science, design science method from Feringa, where we take an artifact. In my case, it was the machine learning workflow, which I will present, and it is a result of multiple iterations to different problem contexts. And these problem contexts are different customer projects, are different settings to solve business problems using AI. And this problem context can consist of software, hardware, people, organizations, services, and many other factors. So, as a result of multiple iterations of this design science method, um, I was able to come up with this machine learning workflow, and there are three modules to it. Because as we see out there, there are so many resources that we are bombarded with so much of information from Google, Amazon, and many other cloud providers. It gets a bit confusing. So this MLOps workflow uh, is developed keeping in mind to keep it very generic, that it can fit to multiple use cases, where we have the build module, where we build the machine learning models using the machine learning pipeline, and then we deploy the machine learning models, and the deployed machine learning models are then monitored using explainable monitoring method. So in the build pipeline, we start, of course, in machine learning workflow by ingesting the needed or acquired data to solve a problem. And after we ingest the data, the pipeline trains the model, and we get the trained model and we evaluate it by testing it with test data. And then once we have good results, we approve it, then we package the model in the needed format in order to deploy it. And before we deploy it, we register it to the model store. And this is the way in which we are able to build machine learning models in MLOps, and then we can deploy the models from model registry. Um, and before deploying, we can of course test the application, and that is the whole thinking behind DevOps mindset to test the deployments before they go into production. So we can have multiple stages. We can have a dev environment. We can have QA, quality assurance environment before we release it to the production. And once it is released to the production, we can monitor it using explainable monitoring methods. Monitoring, again, it's a complex topic, and this is where I think a lot can be done in order to get the business value. Um, I have shared quite a lot about this in the book that I've written, and monitoring component has these three modules. Monitor module, where we can monitor different aspects of the inference data in data drift, model drift, and application performance. Because the data is dynamically changing, we need to monitor the ways in which it changes so that we're able to retrain our models and keep the models updated to the changing trends in the data. So that is one way to monitor the production models, and then we can analyze the models. And in analysis, we can analyze for the fairness of the model using techniques like data slicing, uh, and also we can look for the bias if there is a bias in the model in real time. and also we can look for local and global explanations. So as you can see, monitoring is a very comprehensive module. And as a result of all of this monitoring and analysis, we can govern the whole system. And as a result, we can automate the whole pipeline and the whole ML system. And that is the beauty of MLOps, that we can go to complete automation, or we can have as much as control as we want in the pipeline. And in governing module, we can monitor the errors, potential errors, set alerts and actions to deal with potential errors that might arise, and take actions based on the results from the machine learning model. And those actions can be connected to the real life application. And yeah, these are the ways in which the machine learning workflow, the MLOps workflow, will help us to automate machine learning operations. And on top of the machine learning workflow, these are the 5 different drivers that enable the machine learning operations workflow. Starting from data, as we can see, there's always training data that we have in the data repository. And then there's testing data where we test the developed models. And then, of course, there's monitoring data as a result of collecting the inference, the input data to the model, and also the predictions that we can analyze later and take certain actions by governing the machine learning system. And code, as we can see, we have a training code, testing code, and application code. And as a result of using code on data, we produced trained models. We can package the models, and we can take these models to production. And middleware plays an important part in this workflow, where we use tools such as Git to version the code, and also we used orchestration, container orchestration tools like Docker and model registry, which are part of clouds, usually cloud like Amazon or Azure. And then we use Kubernetes to orchestrate these container deployments, and we can secure the application using virtual nets and different methods. So lastly, all of this is enabled by the infrastructure in form of training compute, production compute, and also the central storage, which stores all the artifacts, the code and data related to the machine learning workflow. And using all of this, we can enable the model retraining, which is an important aspect of continual learning. So by enabling continual learning, we can bring continuous value, a business value, to our problem context. And um, I will just discuss with you 2 use cases that in which machine learning ops helped my customers. Before I go into the demo part, so that we understand the kind of business value it is able to generate. So we had a big Nordic power company, and they had multiple teams working in multiple units, and everyone was trying to do machine learning, and it was in a siloed way. And here is where we developed this machine learning ops workflow for the company, where they were able to standardize collaboration for data scientists. And by enabling such collaboration for data scientists and providing a framework, we were able to free up 20 to 30% of the time from mundane tasks such as training models again and again and not keeping track of them, uh, or licensing with data and also cleaning data and these sort of tasks. So these ended up saving some costs and made the teams efficient. And second use case is where a Nordic hospital had researchers, and these researchers had 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 been using high computation resources such as GPUs, which were running 24/7, and it was not needed to run them 24/7. And using machine learning ops framework, we could enable the compute provisioning facilities to provision the compute whenever it is needed, and this reduced the cost by 70%. And it enabled the researchers to be more collaborative and efficient in their tasks. So these are the ways in which machine learning operations enables organizations by making them efficient and also cost effective as well. So machine learning ops is dynamically developing for the last couple of years, and there's a lot to digest, and there's information scattered all around the web. So I took this. I personally faced this problem of having scattered information, and I took the opportunity to compile all this information in this book. It's called Engineering MLOps, and it's a beginner's guide for data scientists and operational professionals to rapidly test, build, and manage production machine learning lifecycle. So you can find more info about machine learning ops in this book, which is coming out soon in March. But before we go ahead, let's jump into the practical side of it, the demo part. And before we deep dive into the demo, I hope it was all clear so far. Just give me a thumbs up if you're able to hear me, because it was all me speaking all this time.
Yeah, it was great. Yeah, we have a couple of questions in the chat section. Should we address them now or after the demo?
Yeah, maybe we can take one or two now, and then after the demo, we can take some.
All right, sounds good. Let's take a couple of them now. So, okay, first question by Stefan. He asked, how did you manage to monitor drift in particular?
Yeah, so drift can be monitored in three ways. One is the data drift. The data drift, you can monitor the changing nature of the data. Of course, to do this, I've used, there are multiple tools available. Of course, it's a matter of your personal choice. There are tools like visualization tools which help you look at the drift in real time. I can recommend some. For example, Power BI is one where you can run some jobs to assess the changing nature of data. So data drift can be measured like that. And then there's something called feature drift, where you can see the drift in the way features are changing over time as well. So you get some insight. And the drift can be measured using statistical methods like min, max, and their Euclidean distance and other methods that you can use. So there's no one-stop method that can assure you to monitor drift. So every use case can be different, but there's some standardization to it. And thirdly, the model drift is the changing nature of the model related to the data drift. So so this can be monitored by using another model that takes in the input inference data, compares it to the training data, and statistically shows you how the model performance has been changing. So these are the three ways in which we can monitor drift.
All right, perfect. All right, let's take another one. So Thomas is asking, there is a number of commercial platforms available today for handling MLOps. What is your opinion about using one of them versus taking into use the open source tools?
Yeah, MLOps.
And a follow up on that, what are the tools you have? Yeah, go ahead. Yeah, go ahead. Yeah. This is the first part of the questions. We have
I think this is a huge problem. The MLOps landscape is bursting out with a lot of tools. Every day new tools are coming out, and if you look at the nature of these tools, many of the tools are doing the same job. And what I would recommend is to wrap our heads with the principles and the way we can apply to make these principles happen. And I think for enabling MLOps, you need some cloud or some computational some infrastructural service provider which you can rely on. So I would recommend you starting with some cloud out there, at least to begin with, like Amazon or Azure are good to start with. And it's interesting how they're developing their product as well. And in the demo, I'll show you some bits and pieces of how Azure machine learning service looks like and how it enables machine learning operations. So I think it's good to start with one of the cloud providers and then expand the same learning to other tools.
All right. Yeah, and for example, at Tieto, what have you used as a tools and what would you recommend?
Yeah, this is the good part about working at Tieto. I get to work with multiple tools because multiple customers We have multiple customers. So at least I used multiple tools, starting from Azure machine learning service, AWS, and then Valohai, which is also a Finnish company. And what these guys do is pretty fascinating because they're cloud agnostic. They I find that pretty cool because you're not tied to one cloud. So yeah, I've got the privilege of working with multiple tool providers, but there's no one-stop solution that we have at Tieto. We have to be agnostic because customer needs are changing all the time.
Yeah. I think even in the open source field, there is quite a lot of different tools. For example, we have Kubeflow and MLflow, and everyone it differs on if you have Kubernetes resources in the company or not, or if it's a large or a small team. So, what is your take on that?
Yeah, so these are some fundamental principles that are in machine learning ops. The tools basically need to do versioning of the data. Without versioning of the data, it is not MLOps. So we need to see if we are versioning the data, versioning the code, and then, of course, infrastructure can differ from situation to situation, but there's mass adoption to orchestrating deployments using Kubernetes. So I think it's one thing to learn how to deploy containers using Kubernetes on Kubernetes-driven infrastructure. Um, and otherwise, we also need to know how to deploy on-prem as well. So at least these basics, if you know, you'll be able to be agnostic to different use cases.
All right, sounds great. All right, so let's go for a demo now, and after that we can take other questions.
Awesome, let's do so. So this is Azure. I'm going to show you a use case which I implemented for my book. So like out there were less resources which took one use cases and implemented. So I took this chance to create a hypothetical use case where I developed some synthetic data to replicate a situation of a location in Finland. I call it Turku, the port of Turku, where the business problem is that we need to develop a model that predicts the weather 4 hours in advance. So it's a time series, multivariate time series prediction problem. So this is a machine learning workspace, which is quite central to uh, machine learning operations. So this is the hub where we tie up all our machine learning operations. As you can see, that machine learning workspace has the data sets that we used tied up together. As you can see, I've registered all these data sets, the training data set, which I will show you in the meanwhile. Then the validation data set, the raw data set. So you can version your data and it's all connected to this workspace. And then there are the experiments, meaning the model training that I've run. Support vector machine, I've trained random forest classifier to classify if there's going to be rain 4 hours after a given time or not. And you can see the pipelines, the models that you've trained. Everything is connected to this workspace, and these are all the endpoints that you deploy as well. So I've deployed two endpoints. One is the dev environment, where I test out the endpoint for its robustness, and also there's a prod deployment. We'll go into the code as well, just giving you an overview. You can provision computation resources, whatever you want to train your machine learning models, to deploy them. So for example, I've provisioned a Kubernetes cluster here. I've provisioned a virtual machine to train my machine learning models. And then, of course, you can label the data and do all sorts of stuff. So this is a hub for implementing machine learning operations. So I'll just jump into this virtual machine to show you some code of how Azure machine learning at least enables us to implement machine learning operations for any given problem. So you can access your virtual machine like that, and all of us data scientists are familiar with Jupyter Lab, so why not use it? So I've like we've seen in the slides here, in the same way I've developed these steps. The machine learning pipeline has data ingestion, model training, model testing, model packaging, and model registration. So if we look at the code here, this is the raw data set that for the book purpose, I synthetically generated this data. So you're free to use this data to learn, to implement machine learning operations for this data, for this problem. So as you can see, the location is port of Turku because I wanted to make Finland famous. I thought, why not have Turku in here? And then different parameters of the weather conditions like temperature, humidity, wind speed, visibility, and the current condition of the weather, meaning that 1 means that it is not raining and 0 means it is raining. The reason I put this raining problem is because sometimes the logistics at the port is affected if the ships are importing or exporting cargoes. If it's raining and harsh conditions, then there are delays at the port and the logistics get disrupted. So being able to predict weather conditions at a location ahead in times helps the administration of the port to plan logistics, to carry out logistics in a successful way. So that is the business problem we're dealing with here. Um, so of course, the first step is to split it into training and validation data sets. So I've split that, and then I'm registering these data sets using the Azure Machine Learning Service SDK. So there's a Python library which comprises of the SDK functions. So you can use these functions along with your machine learning code. It's straightforward. After splitting the data sets, I register the data set to the machine learning workspace after I make it into a CSV. So you can see the data sets here. They're nicely versioned. And after versioning the data sets, I go to the data ingestion step, which is this step. I ingest the data to the machine learning pipeline and do the feature selection and scaling before training the model. And after we do the feature selection and scaling, I train the model. Here, support vector machine, which is quite popular. Did some grid search to determine the optimal parameters, and using those parameters, train the support vector classifier model. And after training the model, I've registered it to the workspace. And before registering it to the workspace, I package the model into Open Neural Network Exchange format. So this format is getting quite some traction in the AI world because it enables interoperability. Like let's say Sally has developed a model in TensorFlow, and I work in PyTorch. So he gives me his TensorFlow model. I'm able to deserialize from Onyx format his TensorFlow model, and I'm able to work in PyTorch with the same model. So that is the kind of functionality the Onyx serialization format enables. So after packaging the model in Onyx format, I'm registering the model using the Azure Machine Learning SDK. And I can give some tags. I can point to the data set that I used in order to connect the data set to the model that was used to train. So everything is well documented. And in the future, if you want to reproduce the model, you can reproduce with using the same data set, the same hyperparameters that were used to train the model. So that is how MLOps can enable such reproducibility functions and log everything together. So yeah, basically the models are saved to the machine learning workspace. And next, I've used another service called Azure DevOps. This is a DevOps workspace where we can make machine learning pipelines. So here's the code again. Maybe I'll not go much into the code due to the brevity of time here, but I'll show you one script where I'm using again the Azure Machine Learning SDK to infer the model. So basically, I deserialize the model, the Onyx model, from the model store that we saved the model previously or registered the model previously. And after deserializing it, there's this function called run function, which takes in the incoming data from the users and then infers the data and predicts using the incoming data and sends out the prediction if it has rained or not rained, so that the port of Turku authorities can uh, determine or plan their logistics. So in order to do this, I've enabled the continuous integration and deployment features using the DevOps pipeline, the release pipeline. So you can see this is the pipeline where I'm connecting to the artifacts that we previously generated using Azure Machine Learning Service. So you can see the support vector classifier here, the model scaler. So uh, before inferencing, we also need to scale the data, incoming data, to the same scale which was which we used for the training of the model. So if I make a change in my repository, it also triggers the pipeline. So this is the dev environment and this is the prod environment. And I'm deploying my machine learning support vector classifier to the dev environment. And if it is successful in the dev, I do some load testing as well. So all of these you can are meticulously listed in the book on how to implement. So if you're interested to learn, you can refer to the steps there. Due to brevity of time, we can't go into much details, but this is the way production deployments are done. You can see all the logs, and you can, after the endpoints are deployed, we can go to the endpoint here, and we can consume the endpoint and give the users the endpoint information to make inference. So here you can see the code. I can run the inference and show you. This is a sample code where I'm taking sample inference data and pointing to the URL there and performing the inference for each element in the data. So you can see it's predicting no rain ahead in the future. So the inference will keep going on, and you can see the application performance. We have deployed this application, so we can see the performance of the application here. As you can see that we are making requests, and 11 requests have failed. Server has had this many requests, and yeah, these sort of information. So one request has failed, 167 requests have been received, and we can see the server response time is 2.16 millisecond, which is quite decent for this use case. And yeah, these sort of information that you can see about your service. And this is the way you can build your machine learning models, deploy them, and also monitor the machine learning models. So yeah, that in a nutshell was the demo, a quick demo. Maybe the last 10 minutes we can take questions.
All right, perfect. Thank you for the demo. It was really interesting. Yeah, let's take a couple of other questions. So Hanan is asking, regarding continuous learning, do you feel that online machine learning algorithms that can be updated as raw data comes without needing to retrain from scratch should be preferred to their type of algorithms?
So I didn't get the question. Can you repeat again?
Yeah, so regarding the continuous learning, do you feel that online machine learning algorithms that can be updated as the new data comes without needing to retrain from scratch should be preferred to their type of algorithms?
Good question. Yeah, I think it can be smart to start from a pre-trained model, use some transfer learning capabilities by not starting from scratch. That is one way to do. So machine learning operations also enables transfer learning. And of course, you can keep updating your model periodically to implement continual learning, and it keeps the model updated in that way. So the smarter you are, the better it is. If you're able to start from a model which is already pre-trained, you're able to make it learn by using transfer learn. That is smart. So there's no one way to go about it. It's about solving your problem in the most optimal way.
Yeah, definitely. All right. So Yoha is asking, Do you have any experience with using challenger models? Two models side by side, where one is used for production output and the other is the challenger for monitoring the quality, detecting gradual degradation for the production model.
Yeah, I have some experience working with that. Is there a question around that?
Yeah, so what was your experience about that?
Yeah, it is quite useful to assure the quality in real time to see how the models are performing in the production model, and especially we can validate using the challenger model. That is one innovative to do inference in production. But yeah, there are other ways as well where we can A/B test, and also every use case is different. So
All
it's
right.
yeah,
Yeah, that's an
it's
interesting.
good to be use case agnostic.
Yeah. Yeah, but yeah, I like the idea of the challenger. It seems interesting. I should read more about that.
Yes.
Yeah, all right. So another one from Lowry is asking, how do you find the workforce to implement MLOps? Do you train data scientists to understand DevOps, software developers to understand machine learning, or do you train dedicated MLOps engineers?
So I personally feel like it's good to have dedicated people for dedicated jobs. And if you have data scientists who are good at developing models, it's good to keep it like that because there's a lot to learn and the ecosystem is evolving.
Yeah.
So if one tries to be a generalist, that one might not be good at narrow tasks, or there's a lot happening and it's hard to keep up with the changing world. So it's good to have data scientists dedicated to develop cutting edge models, and then machine learning engineers can of course be updated with machine learning ops because it will be there for a long time, and it is evolving to serve the future business needs and the current ones as well.
All right. Okay. Uh, all right. Yeah, there is another question from Nisrin. She's asking, how do we integrate, I guess, the MLOps platform with the company's website or the company's platform?
So you can easier way to do it is by using a REST API based ML service that you can develop using machine learning ops, and then you can integrate your REST API endpoint to your website to serve the user needs, and that way you're able to keep your machine learning operations separate from web development or the application development for your company, and keeps it easy.
Yeah, definitely. Yeah, especially most of those cloud providers, they prepare endpoints that you can quickly consume in a
Right.
restful way. Yeah, cool. Another one from Dennis is asking about the demo. What are the triggers for training of the weather support vector machine model?
The triggers for the pipeline.
Yeah,
Yeah, I can maybe share the screen once again.
sure.
So the triggers here are, of course, changes in the code. So I've enabled that. If I commit something to the master branch, for example, it triggers the pipeline. And then for this demo, I've kept, if I train model scaler, I've enabled the pipeline, but this is not a good practice. Don't enable the model scaler, but rather go for the model. If you train a model, then enable the pipeline, and it depends from need to need.
Yeah. Okay. Yeah, I think we don't have any other questions.
Mhm.
Actually, we started a poll just to know all of the attendees, to know your backgrounds. So please vote if you are a data scientist or a data engineer, or just to have an, idea about the.
Mhm.
All right.
I, I have a last thing to share with you all.
Sure.
So, about the book I previously shared. So, I've been working with a publisher to get that out, and the publisher promised to send some of us the free book. So, there's a chance that some of you, if you're interested to learn MLOps, the book I can send you out for free. So, there's a free giveaway that we can make happen, and it would be for the first 15 people who reach out to me for the first come first serve basis.
All
So I'll be able to send you a free ebook in 10 to 15 days of time. That the only thing that you might help me with is give a review on Amazon, because it helps get the message out and to really know how the book is. So
sure.
feel free to reach out to me on this email um, if you're interested to get a free ebook.
Sure. All right. Yeah. Yeah. Thank you for the freebies. It's always good to have free stuff.
Definitely. I love freebies as well.
Cool. All right. I think that's it. We don't have any other questions in the chat section. I think we can wrap it up. Yeah.
Mhm.
Feel free if you have any other or final words
Yeah.
before.
Thanks, first of all, PyData and the team for inviting me.
Sure.
It's a pleasure to be able to share this idea, and it's quite amusing that still in pandemic days we can come together like this and share knowledge with each other. And personally, if you're a software engineer, data scientist, or aspire to be a data scientist, I encourage you to learn machine learning ops, because this is the future of operationalizing machine learning on scale. So this is becoming industry standard day by day, and it can be quite rewarding for you actually to learn machine learning ops for your company, for your team, and to solve your business problems in the most optimal way. And also, I'm here as well. Feel free to reach out. Always like brainstorming on different questions. So feel free to reach out to me on LinkedIn, and I hope to be stay connected with you all. And thank you very much for your time. Thank you.
All right. Yeah. Thank you, Emmanuel, for the presentation and the demo. It was really interesting. And thanks for everyone who attended this meetup, and really looking forward to see you in next month meetups. Stay safe and bye-bye.
Awesome. Bye bye.
Bye.